Yeah.
Yes.
No,
Palo Alto to Gilroy is 1 million people.
Oh, yes. No, I used to live in Palo Alto.
Would you?
In fact, we're going out there tomorrow night.
I live in Saratoga, just west of San Jose.
But all of those who used to live there, I think it's all ruined now.
It is. Yeah. And I never lived there, but I can remember going out there in the early days, in the like 1954, 55, when it was much less populated than it is now.
Yeah.
And it was just charming. I mean, places like Saratoga were just charming little places.
Right. Oh, yeah. I lived in Menlo Park till I moved here in '53.
Well, Menlo Park now. Well, Menlo Park is still very important. Just opposite on Sand Hill Road there.
Yeah, but it's all built.
Yeah. I have a very good friend that lives off Sand Hill Road in one of these condominium developments.
Yes.
It's excellent. Beautiful.
Yeah.
Very handy.
But there were no condominiums. There were horses.
Yeah. Well, if you go out just another half mile, the horses are still there.
Still there. Yeah.
When did you live there?
Till I moved to MIT in '53. Yeah, I've been here for a while.
Yeah. That's good.
And that, how much can you talk about what it is you're going to be doing?
None, really.
None.
Well, I can tell you what I've been doing, and I can tell you that what I'm doing is a sequel to it. I decided about 10 years ago that it was very important. It would eventually be very important to have access to computing from wherever you were and whenever you wanted it.
You have a choice of apple and grapefruit. These are artichoke nuts.
Yes. So wherever you were, yes, exactly.
And originally I visualized this as being that you could have a terminal wherever you were, and if you could get to a telephone, you could connect to it, and then you could be on a computer.
Yeah.
And so I looked at the terminals, and I figured there were two terrible problems. One is the display, and the other is the keyboard. The keyboard is much too big, and the display is much too big. I went to work on the keyboard first, and I developed a keyboard that's about this big, in which you can type with one hand, about as well as you can type on a regular keyboard with two hands.
Oh, really?
About as fast and about as accurately.
It's a comptometer-like arrangement.
It's called a chord keyboard. You make chords like in an octave on a piano. And then I went to work on the rest of it, and by that time the microprocessor had been invented, and so it was obvious that instead of being a terminal, it should be a computer of its own.
Sure.
And so I built a portable computer that I could carry around. This is using MIT students, and later I changed from MIT students to Northeastern students, because I'll explain why later, but let me tell a story first. And so we developed a computer that was portable. The technology wasn't available to make a good one. The technology is just becoming available now. And I had that running, 2 years ago anyway. And so I could carry it around, and I could use it. I could go to meetings. I could take it in airplanes, and I couldn't use it in the airplane, but because they had to plug it in.
Yeah.
In order to use it. I originally planned to have it battery operated, but that didn't work out. And I discovered a number of things about portable computers. One is that they have to be battery operated. The reason they have to be battery operated is, I'll just give you a couple of examples. If you're an armand and you go into somebody's office to demonstrate something to him, the chances are 50-50 that there's only one electrical outlet in his office, and it's behind the bookcase that's too heavy to move.
Anywhere.
And if you're in a airport departure lounge, in which I spend a certain amount of time, it takes a while to find the outlet, and it's usually not very convenient to use. And if you're in a restaurant, it's impossible to find one. Well, not quite. Once in a while you find a restaurant. So it should be battery operated. And furthermore, unlike the IBM PC, it has to operate at once. That is, the uses you have for a portable computer do not allow you to the luxury of waiting until it studies itself to see if it's working.
Yeah.
It has to work the instant you turn it on. And it should be battery operated, and it should work the instant you turn it on. And our culture provides you with 8.5 by 11 inches to set it down.
Yes.
If it's a lot larger than that, you won't find a place to. See, right now, I could set it down right here.
Yes.
So we're 8.5 by 11 inches.
Yes.
And if it were a lot larger than that, I wouldn't be able to set it down. And if it were a lot heavier, we took this table. If it were like 4 pounds is all right, but 12 pounds is much too much.
Thank you for the rifle.
Okay,
Yes,
so
12 pounds is too much, yeah.
I'm involved in a project which uses what I've developed, but I can't tell you.
No.
I can't describe the project or what it's
Sure.
doing.
Put in the lettering
It's going to be a surprise to the Japanese. I hope. I hope they're going to be dismayed.
I'm sure it'll take two.
You give them a letter of intent.
Letter of intent, whatever it is,
Yes,
I'll take
he'll
two.
give you a letter of intent,
Okay.
all right?
That's a good code name for the project, Dismay.
Dismay.
In fact, a good part of the last half hour that I spent when I ran off to my office from you was making arrangements to be able to communicate with Multics here from my son's micro in Seattle, where we'll be visiting, so that I'd be in communication. But it took it took 20 minutes to see that that I had all the numbers and that everything was arranged and so on.
MIT graduates will be great customers.
Yeah, that's right.
Do you want to know why I don't use MIT students
Yes.
Yes, why did you switch to Northeastern?
anymore?
Why?
I do use. I just used one this last term.
When you give them the question, you'd be very leery.
I have an answer. Because they don't like to be used.
No, they're very good. But I was designing this computer, and I wanted guys who were creative and would work hard. And IBM has rules. And I had 3 manpower slots for students. And if I used an MIT student, I couldn't get the best ones because the professors used them up.
Yes.
But I could get very good ones. But for 1 manpower slot, I would get him full time in January, 12 hours a week, full time during the summer, and 12 hours a week otherwise, which is half time.
Yes.
And at Northeastern, I get a full time student. You're
Studies
familiar
in
with that
evening.
setup. And so for what I was doing, and in my status, which is it was much. I could make much more progress in my project with Northeastern students than with MIT students.
Yeah.
However, my status is that I'm mainly an IBM employee, and I'm a little bit of faculty member. I'm a visiting scientist.
Yes.
And but I just this last quarter, or this last 4 months, 5 months, last term, MIT term, I did something with an MIT student that you may be interested in. You've perhaps heard about CAI, computer-aided instruction,
Of course.
which teaches well.
That's what my son does.
Oh, that's right. Yeah. I told you this whole story. I shouldn't tell it.
Tell everyone. Go ahead.
Tell to the world.
Yeah.
Computer-aided instruction teaches people well, efficiently, as long as they stay awake. And but taking a computer-aided instruction course is hard. I mean, it's not fun. However, playing a video game was a lot of fun. It's very intensely attractive, at least to young men, and actually to a lot of people. But a lot of people are embarrassed about playing video games because it's a waste of time.
True.
And so, and other people are afraid of video games because their kids outperform them, and there are all sorts of circumstances. But anyway, a whole lot of people spend a whole lot of time playing video games and put a lot of quarters into the machines. So it occurred to me that if you combine CAI and video games, you could have something really good.
They can put a quarter in.
And well, no, you have to. There's a whole thing about video games. What makes a good video game? So this student,
I'm just trying to make
Ken
CAI.
Krugler. Did you ever encounter Ken Krugler?
No.
He's a senior, or was a senior. In the first term, he took an EE subject, which is a special subject that I taught, and he was the only student. And he wrote a report, which you can get. It's going to be published as an LCS report. Or it has been published. It's read about now on the stage of being published.
Yep.
On CAI and video games. What he did was to analyze the whole thing and figure out how this could be done, what could be done. And then in the last term, he applied a small fragment of his great grand plan and wrote a program to teach typing. And what happens is this text is displayed, and there's a cursor under the beginning of the text, and then there's a little shark up there that eats text, and you have a head start on him because there are a bunch of null characters up at the top that he has to eat before you get to the text, and so you start typing. The shark starts eating these null characters, and as soon as and the characters you type light up, and every time you make a mistake, he jumps ahead some number of characters. You get to choose how many characters he gets to jump ahead, and you get to choose how fast he eats. And if he catches up with you, he eats you.
You're trying to say just ahead of Jaws too, huh?
The game is called Jaws.
Is that right? I was not aware of that.
You got a copyright problem there?
And
I think Universal would take it into view of
How
that.
can you copyright a generic word?
If it's a shark.
You can have a movie named Jaws, and you can have a street named Jaws, and you can have a program named Jaws. And what's wrong with that?
Well, just so long as it doesn't look like a shark.
Our neighbor has a dog named Jaws, and it's a monster.
Anyway, so the reason I was late.
I'm fine, thank you.
The reason I was late for our luncheon last week was because I was playing Jaws, and I got so interested in playing Jaws and trying to beat the game to be able to increase my the speed and let the shark start closer, that I forgot completely that I was due to have luncheon with him. So I was a little bit late. So it may have succeeded. I don't know.
It sounds like a good game.
I can't wait to see.
When would you like to have dinner?
Well,
It's 6:45 that you have to go, Mr. Haddad.
Mm-hmm.
Yeah.
Oh, well then you can.
So we should have dinner at about 6?
We should eat at 6. That will enable you to
All right.
have dinner. And
Why don't we use some of the remaining time to talk about von Neumann? As you left, they told some really great von Neumann stories.
all right.
I think we should start with the one, your idea of why you think von Neumann was so powerful as a technology transfer, is that what we're going to call it?
Well, what happened is, Birx, von Neumann, and Goldstein published a report that described how to build a computer, which was fantastic. I mean, it just changed everything. Not quite everything. You'll hear about something it didn't change in a minute. And a whole bunch of people went to the 1946 summer school at the University of Pennsylvania, and they heard about all this beautiful idea, and they went back to their places. They started to build computers, and one of them was Whirlwind. That's how I got in the act. And there were a whole bunch of others all across the world. And finally these computers came out, and they sort of formed the foundation of the computer industry and the computer technology. Now, how did von Neumann understand how to design a computer? Where do the ideas come from?
Yeah.
Now I'll come back later to the fact that not everybody learned how to build computers from there. One of the exceptions is Maurice Wilkes, who was the first one to get his computer running. He didn't learn it from those guys at all.
Really? I thought his was an IAS machine.
It was, but he didn't learn it. He didn't learn anything from those guys.
Really?
And okay, now he claims he didn't learn anything from those guys. All right, now here's my theory of how von Neumann was able to produce this thing. His talent was that you could you could describe to von Neumann an idea. You were very enthusiastic about this idea, and you describe it to him. And the average idea that the average engineer produces and describes as a kludge.
Yeah.
I mean, it may have some essence of good in it, but it's not very well done. And so you describe this great thing you would be very enthusiastic about to von Neumann, and he would say, "Here is what I heard you say." You take a piece of chalk and you stand up on the blackboard, and he would describe something that was much simpler and much more powerful. And he would describe it more beautifully.
Yep.
Than you had.
Yeah,
the initial presentation.
Yeah, it was much better than mine. And so this is how I was able to use him as a consultant, was to describe things to him and then get them back straight, put in shape, and it was wonderful. Yeah. Well, I figured that he went over to England, and he knew about Turing's paper, and he knew Turing, and he was sort of senior to Turing, and he had complete access, because everybody gave von Neumann access to everything.
Yes.
And so Turing was building this machine, which wasn't a computer. It wasn't a general purpose machine in the sense of a Turing machine. And Turing described to von Neumann a very fuzzy idea of what should be done to make a real computer, or they talked about it somehow. And then von Neumann went back to the United States, and with the help of Burks and von Neumann, Burks and Goldstein, said, "Here is what I heard you say." And that became this fantastic document.
And so you don't think that it was the ideas that Burks and Goldstein were talking about, that they weren't implementing on ENIAC, but rather that it involved the English dimension as some important additional ideas?
Yeah.
Yeah. Because, of course, there are those who argue that, I mean, they're obviously, everybody, this is a dogfight. Everybody claims to be the originator. But there are those who argue that Eckert and Maudsley simply weren't doing some of the things that they perfectly well understood because they were in a hurry to get a machine going. But you think there's more to it?
Well, now let me describe Wilkes' relation to all this.
Yeah, please.
I originally, in talking about this concept, said, and the first person who went back from Princeton and got his machine running was Wilkes.
Yep.
And so I talked to Wilkes about this. And he said, "No, that isn't what happened at all. Those guys didn't even get it right." And I don't know, but he would never describe exactly what relation he had with Turing,
yes,
or who he had a relationship with. But the implication was extremely strong. No, it was more than an implication. He said, von Neumann and I got our information from the same place. And and when I went there, I didn't go as a student, I went as a teacher. And I hadn't really gotten the thing right anyway.
I see. Okay.
And he wasn't there full time. It's summer of 46.
He wasn't there through the whole course.
He only was there part of the time.
This was
Part of the time, I see.
He was sort of
That's
wandering
interesting.
around, picking up information.
Yeah.
Who's this?
Wilkes.
Now, at that time, we didn't need Turing, we didn't need von Neumann, or anybody, any of the main people in order to get computers going, because the ideas were in the air. The difference was that Turing and von Neumann each contributed some awfully powerful thinking to it. I mean, there were a whole bunch of guys that, "Oh, this is wonderful, you can make this thing." And if you'd given the guy $1 million, he'd build you a kludge. And Turing had the marvelous idea of a universal machine.
Yes.
Which nobody else had expressed, but he said it so early, it was hardly relevant.
There was another article, Price,
Post.
Post,
At the
simultaneous.
same time, but
Really?
the same month, a similar article was published. Never tracked
as
down
the Turing
this Post,
paper?
whoever
Yeah,
he is.
yeah.
His
Yeah.
Turing
Post was a
paper.
prominent logician.
Yes.
Yes, but I never bothered to find out more when anybody read it or anything like that. It was just, it's in
He
the...
didn't have the influence.
And then at the same time, in an obscure journal by a very influential person, Vannevar Bush, is a similar paper published in some very obscure mathematical aid, not aids to computation, something nobody ever would think of. And he simply described a virtually a general purpose automaton that could be done digitally, but he didn't follow up on it.
Well, look, the notion